Hello. Today is January 21st, 2025. This is SIG Node weekly meeting. Welcome, everybody. Today on agenda, we have first item is from John about DRA. John, do you want to present or you want me to present? Like how?
I can present. That's fine, assuming I have the privileges. Let's see. So yeah, Peter asked me a few weeks ago to go through the things we're planning for DRA. And I'm not going to go through all of these in detail, but I wanted to just raise the visibility. This was on the agenda last week, but we didn't have time for it. So, and there's actually probably, we just came out of the SIG working group meeting, SIG, the work group devices meeting, and there were a bunch of other things on there that people are interested in doing that aren't even on this list. So a lot of them fall into SIG scheduling or even SIG auth for one of them. So what we're trying to do is, as we go through them this week, we're going to try to make sure that we want to keep SIG Node informed as to what's going on, but we don't want to put things on SIG Node's leadership to have to review that actually don't touch any kubelet or on-node code or the directly related APIs. So so just wanted to make that clear that although there's a long list here, not all of these things actually land squarely on SIG Node, but they are, things SIG Node at least should have some awareness of. Probably doesn't need to approve all of them. So just to quickly track through the ones that we have in the document, I'll probably just take 5 minutes for this whole thing unless people have a lot of questions. This is a SIG Node one. Sergey's got this going around making sure that DRA device status is reflected in the pod status for the end users. This idea of partitionable devices is one we have for, actually has two parts. One is, or two primary use cases. One is breaking up devices into smaller devices. So like large GPUs into smaller GPUs and being able to allocate and schedule them just like we do full-size GPUs, and account for the overlap between different types of partitions. So like a large partition and a small partition. If you take the large partition, some of the small partitions are no longer available. We also can use this for, in a multi-node situation for sets of nodes that can be allocated together as a unit and utilized as a unit. So that's kind of an interesting use case if anybody's curious. That is SIG Node owned, although I'm not sure it will stay that way because it's actually pretty much all scheduler code. There's no changes to kubelet. There's no changes to DRA kubelet driver interfaces. There's no changes to pod spec. There's a change to resource slice and API. So unless there's opposition from folks here at SIG Node, likely we will move that to SIG scheduling. Prioritized alternatives in device requests. This is, I have a claim I make, and I'm allowed to provide. You can satisfy this claim with device 1 or device 2 or 3 of device 3, and I can list those in order. This is 100% done before it ever reaches kubelet. So again, this one already was SIG scheduling owned in last cycle, and that's mostly done. We've got a few. We've gotten some feedback on the API. We're going to tweak and then revise the implementation to match that API. So we expect that to actually be hopefully merged before enhancements freeze, even like the whole implementation, which would be awesome. The next one will be SIG scheduling owned if we even make any progress on it this cycle. This is about scoring. In general, scoring is marginally useful for, I mean, there's cases when you add in the the two caps that I just mentioned, scoring becomes much more relevant. So what happens is with the partitionable ones, normally today we have homogeneous nodes, meaning all the GPUs in a node are the same. That's almost anybody in their right mind does it that way. However, once you go to partitionable, that's just no longer the case, right? Because the same node has a big GPU, or it can be consumed as two small GPUs, or four even smaller GPUs, or seven even smaller GPUs. And so now there's many options on the same node. This is where node labels and device plugin just kind of fall apart. So this is exactly where DRA is super useful. But you can imagine now if I come in and I say, I mean, the way we'll implement it without scoring is the vendor will list the devices in the order they should be tried first in the resource slice. So they start with their small devices, and then their medium-sized devices, then their larger devices, then the full, the full device. The idea is, right, I come in with a request that says, I need a GPU that has at least 8 gigs of GPU memory. And so what partition can I satisfy that with? Right now, without scoring, the only way to control that is the vendor to list the things in the right order and for us to have a deterministic order in which we try them. Otherwise, you could allocate the whole GPU when a smaller partition would work. Scoring would alleviate that in these heterogeneous node situations such that we could score how good the fit is and then just choose the one with the best fit. But it's super complicated, and there's many, if you click on that issue, you'll see there's like 4 different points of view of people who would want to influence the score. I don't know how much progress we're going to make on that, but I want to have awareness of it here. Handle extended resource requests via the DRA driver. So this is also probably more scheduling, but I definitely would want SIG Node to either approve or be closely involved because it touches that extended resource API, which is closely related to everything we do here. But or some things we do here. The idea here is that as people move forward with DRA, this is something I want to get. I want to get this functionality into beta before we can GA, at least into beta before we can GA DRA. So the idea is device plugin right now, if you put in the request in the extended resources API, it can only be handled by nodes running device plugin. If you put the request for resources in the claims API, it can only be handled by nodes running DRA plugin. So for devices that, for which there's an existing device plugin and there's literally, hundreds of thousands, if not millions of manifests out there with that in it, that's a problem. If you can't upgrade your DRA, your node pools to use DRA, and all of those, it's a problem if all those manifests stop working. So we have to figure out how to do that. The proposal under discussion here, Kevin raised this a while back, and kind of the current thinking is something like an extended resource name associated with a device class. And then you have a mapping from extended resource request to a device class to DRA. But SIG scheduling is like, well, then you have to do DRA for everything, which has some additional API calls and might affect scheduler latency, blah, blah, blah. So we have a bunch of, or throughput rather. So we have a bunch of things to work through there, as well as the sort of migration. I take this issue as sort of the whole migration path of how we concurrently, the device plugin will be around forever, and it might be the best solution for certain types of devices and or certain use cases for specific devices. So we need these things to live happily together, but without users having to go through a lot of pain to understand which API they should use and then which nodes might pick up those pods. So that's what that is all about. I think there will be that one's probably one of the most ones that people here will have the most opinions about, I would expect. Next one, admin controlled device attributes. This is probably moving to SIG scheduling. Also, this is kind of an ability for the admin to overlay and take out of service a device, for example. I recently added, I haven't reviewed any of this yet, but we just talked about it in the last meeting. So I can't say too much about it since I haven't reviewed it, but there's also a concept of device taints and tolerations, analogous to node taints and tolerations, such that an administrator can taint a device and a user can tolerate that taint within their resource claim. Again, that's a scheduling construct more than a node construct, but obviously relates closely to node as well. Admin access for resource claims and resource claim templates. This actually is probably moving to SIG off. I think Rita wants to move it to SIG off because really this is about, I don't know, we'll have to have the discussion. It's about off, but it's about accounting, right? So the idea is that we call it admin access right now, and maybe that's what it'll be. Maybe it'll be more of that than I realize. But what we had talked about in the past was this was an accounting trick. The use case is I have a daemon set that monitors the health and metrics of all my, say, NVIDIA GPUs on a given node. So I want to run that daemon set. I want to allocate those GPUs for it, but I don't want to take them out of service for other users. So it's a transparent allocation. And so they get plumbed in to the device, to the pod. So the DRA driver gets called and all of that. We don't need it to be a privileged pod. Basically, we're trying to make it so that this monitoring solution doesn't have to be a privileged pod. So what we do is those get, we say we want all the GPUs on a given node in admin access mode, which just means we give them to you, but we don't account for them, so the scheduler can still use them for ordinary user pods. Again, there's no changes to the DRA driver interface to kubelet. There's no changes to kubelet here, so probably this will fall under a different SIG. This one is new. So the idea here is disaggregated devices. So Boxo GPUs attached with a PCIe switch to a handful of nodes, and you can move those GPUs between nodes, or even clusters I'm hearing now. So Boxo GPUs attached to multiple Kubernetes clusters. How do we manage the life cycle of attachment of those devices to nodes? This seems like SIG Node is going to have a vested interest there because we're I don't know. I think that's done outside Kubernetes, but I think everybody here needs to be involved. The leads here need to be involved. Whoever needs to be involved to make sure we don't do something stupid. That's super interesting. There's actually a few different kind of interrelated caps, this being one of them, that we're going to try to address with a single design, we believe. So I think the SIG Node folks will want to be involved in that. And this next where it says no issue yet, new device model for pooling or per device allocatable resources. That also is one of those caps I just mentioned that's kind of interrelated. The idea here is take what node does with allocatable resources, but stick it in a device. So now you can say allocate 2 gigs out of an 8 gig GPU. There's a question of whether the underlying GPU in that case supports that. But where we know it's supported is things like CPUs. So Marlo is super interested in this, and I know that some folks at KubeCon last time talked about creating DRA drivers around CPU. So this is also an area related directly to standard or native resource management. We'll have similar issues should we go forward with something like this that we do with extended APIs, as far as like in certain cases, if a yeah, there'll be a lot of issues to sort out here. So I think folks in this group will be really interested in being involved there. And then one other one I put here, no issues yet. There's some, this I would say is completely SIG scheduling as well. It's basically, we have match attributes right now, which says you both have to be on the same, say, PCIe bus. This is a way to do it with cell expressions that's more complex. I haven't actually seen this raised again. It was raised last cycle. So I don't know if this is really on the board. Yeah, Francesco.
Hey, thank you for the breakdown. And indeed, I'm very interested in the extending DRA to CPU and memory. I share their interest. So I have a couple of logistical questions, which is, in your view, I mean, just your perspective today, how's the priority of this work compared to other? Because it seems to me there is a bunch of DRA related stuff ongoing.
Yeah, exactly. I have my priority list, but everybody else has their own too. For me, priority is actually starts from the bottom here. So I actually got, those are all the alpha things. There's actually a bunch of things here as well. Some of these are like actually now people are saying they want to do more than anyway. But my priorities, I can give you mine. Mine are figure out exactly what we need to do to get to stable in 134. And what that means to me, most likely, is figuring out the path for this CAP, okay, how we handle the extended resource request API. And then, so those are, I would say, my top two priorities because they relate to getting it to GA. Then my second priority is probably partitionable devices, and then this one basically because it's just about done. So all of these others are super important to me too, and they're even probably more important to some other people than the ones I mentioned, right? So the group as a whole, I wouldn't say has a single list of priorities. We all have our own, but those are the top things to me. I tend to divide these into a couple categories. The other top priority to me, well, gets into the GA thing, is Sergey's raised many times, and he keeps beating this drum, which I appreciate, is a bunch of verifying reliability and things like that. So that's another aspect. But so I tend to divide them into a few buckets. One is expressiveness of the claim API. So that's like how can we select and allocate devices. Two is expressiveness of the resource slice API. So a lot of these are related to that, right? How do we do attachable devices? How do we do partitionable devices? How do we do per device allocatable resources? How do we do CPU management? Like all that's on that device model side. The great thing about that side is that it's a smaller group of people that have to understand it. So because it's mostly the device vendors and cloud providers and people doing node stuff, as opposed to end users. I think we can have a lot more chaos in that space with these alphas. And then the administrative APIs. So the ones like admin control device attributes. That's like overrides by the admin or pulling things out. Admin access flag is kind of, I mean, that's a claim expressiveness side, I guess. But so those are kind of and then the driver and reliability side things would be the fourth bucket. So anyway, that's my take on things. And I think I think we all agree as a working group that getting it to GA as soon as possible is our top priority. So that's the organizing principle.
That makes full sense to me. The reason I'm asking is because I totally see why we want to GA as fast as possible. I do. Thing is, extending, okay, and speaking, I'm really selfish, but extending the DRA to CPU and memory could, and I really emphasize could, stretch the API concepts and model in a way which was unforeseen, because CPU and memory do have some, special, are kind of special. Not right. It's kind of hard, in my opinion, to model them like a regular device. So I fully again understand and support the let's call it rush to GA, but I'm a bit concerned that postponing them could shoehorn the representation. And I guess there is no solution, and I guess, but I'm just voicing my gut feeling in this area.
Yeah. So I mean, all the CPU stuff would be like, that's alpha, right? But if you're saying that we might, so we're definitely, so 133, we do plan to do a V1 beta 2. And then 134, that's my personal, somewhat aggressive goal to land in GA. But I think that we need to have a very serious, like I don't think it's overly aggressive to say we need to do it in 2025, which means 135 is like kind of the outside edge of where I'd want a GA. That's my point of view. I really do want to get in 134 if we can. So I would love, I mean, we can have more discussions and look at how the proposals are coming together, and you know, that's what we do, right? So would love, absolutely love your involvement in making sure we don't do something that's going to be. By the way, I also think this is an option to have a sort of two-factor allocation. So like GRA is used for certain aspects of attributes, but not necessarily for the core piece. So there's a lot of options we need to discuss. I see a hand up there.
Yeah, Mrunal here, sorry. Yeah, I'm definitely supportive of going to GA. And I think one thing probably in the cap I need to read is, are we tracking the adoption by actual drivers that are being shipped? Like, for example, I think NVIDIA has plans to get it into the GPU plugin. Do we have other vendors lined up? Do we need to get at least one networking driver or something? Just to make sure that...
Yes, we do have. I'll show you the criteria, and we can debate whether this is sufficient. But the criteria we have here for GA, at least 3 real-world driver implementations from different organizations. So we should have at the very least, but that doesn't say one network, one GPU, like, right? So we might want to make that even more stringent, but we know for a fact we're going to have probably 2 or 3 from Google. NVIDIA has at least 2, maybe 3. Right. Intel has at least 1, probably more like 2 or 3. I don't know if the Intel folks. Okay, so we will definitely meet this criteria. But if we want to like extend it to like make sure some are network. Okay, 1 to 3. Sasha says, okay, yeah, we'll have one for TPUs, single nodes, like single host node TPUs. We'll have one for multi-node TPUs. NVIDIA has IMX channel 1 for multi-node things. They have the GPU one for GPUs. They'll probably have an RDMA NIC one for Mellanox, right? So, and Intel probably has similar. So I think we're gonna have tons of them. Okay, were there any other hands, or I'll just quickly, just to be like, this is my private tracking thing, and you'll see all these gray ones. These gray ones don't even have issues yet. I don't know how many of them will actually land with issues in 133, and how much will actually do, because there's just not capacity to do all the things we want to do. But just awareness that the ones that are in the document were the ones that were they all there a week ago, and there's a handful of new ones as well that people raised today in the meeting. Hopefully by the end of this week, we'll have a better, clearer picture. And like I said, we'll run them by everybody here and ask for which ones we think need SIG Node approval versus more SIG Node consultation.
Sounds good. And John, like I can volunteer to help with the SIG Node approvals, like the previous
Awesome.
one.
Thank you, Ronald. Okay, that's it for me.
Yeah, some of them like partitioning devices. I would really be interested, like how, like what will be happening on Node to partition and allocate, deallocate. So that kind of consultation we probably will be looking at.
Yeah, so there will be like, so when the node prepare resources gets called, it will probably make, in the case of NVIDIA, make calls to the GPU to repartition the multi-instance GPU. And then, right, later when the binding or when the mounts or when the CDI, it goes through CDI. So when that happens, it'll actually, mount that newly created device effectively into the pod, into the container.
Yeah, all sorts of timeouts and recovering from failures. I would be interested to SIG Node. But yeah,
I think that
the SIG scheduling, but then we can look.
so there's two other ones I think you're going to be super interested in that case, Sergey. One is this attach devices to nodes, right? There's actually, it's kind of like volumes, right? It's like it's a separate, it's over a separate fabric. Two, and those can fail because maybe we have two clusters that have access to the same GPU, and so the schedulers don't work together, so it's no longer available. So right, there's failure modes. There's another one that I found out about today that looks really good. It's something we've talked about in the past, but it's been further developed quite a bit, which is similar in that it's for you provision devices in order to satisfy the request. It's just that they're often like virtual interfaces. Like if you want to provision a VLAN interface or something, and then add that into but it's into a container, but it's or in a pod rather. It's kind of it's analogous, but it's all on node rather than like the driver would run on node and it's just a bunch of kernel syscalls to create them, as opposed to attaching something that's off node. So there's different failure modes, but I think the same design and same model can probably handle both, but we're gonna have a life cycle model that's kind of distinct from the pod, and we're gonna have to work on this. It's gonna be complicated. So.
Makes sense. Thank you.
Yep. All right, back to you, Sergey.
Okay, from just admin task perspective, we Kubernetes moving to this Kubernetes IO domain for all the groups, and we started this migration some time ago, and like we will continue on that, and soon most people will be automatically joining the other Google group, and we will deprecate the old groups. I'm fighting some permissions right now, and hopefully I can resolve it soon. Another announcement that we have is from Francesca. Francesca self-nominated for approvers for sub category of for devices and managers, like resource managers. I strongly support it. I wanted to bring to everybody's attention.
Yeah, I just added +1. I think I will just we can ask Don and Derek if they want to +1 it as well, and then we can get merged.
Perfect. Yeah. Thank you, Francesca, for continuing support and contribution. Is there anything else? You can go now. Otherwise, we have 26 minutes by.
Yeah. This sounds good. I think maybe next week we can start 133 planning. So folks, if you have topics, bring them next week.
Yeah, next week we'll start doing cap triage and understanding what will fit in a release and what will not. So if you have anything you want to work on, please bring to the next meeting, and make sure that you spoke with somebody to line up some reviewers and approvers. Thank you. Bye-bye, everybody.
Thanks. Bye.